Hi guys, this is Anna, Annie, and Chris with homework number 8, problem number 4. So in that problem, we are given that a function is integrable on interval AB, and if there exists a differentiable function, capital F, on that interval, such that f prime is equal to f, we want to prove that the integral from a to b of a function f of x dx is equal to f of b minus f of a. So let's get on with the proof. Since f is differentiable on that interval, and f prime is equal to f, and also by applying the mean value theorem, we know that there exists a t sub I, an element of this interval here, such that f of x sub I minus f of x sub I minus 1 is equal to f prime of ti of x sub I minus x sub I minus 1 for any I 1 through n. Again, this statement here is coming right from the mean value theorem. Now, since f sub prime is equal to f, we can replace this f sub prime with lowercase f here. And since this equals that, we can take the sum of both sides and make the following statement. The sum of f of ti x sub I minus x sub I minus 1 is equal to the sum of capital F of x sub I minus f of x sub I minus 1. So bring it to the next slide. What we'll do next is expand this right-hand side. So from I sub I minus is equal to 1 through n, we can expand it into f of x sub 1 minus f of x sub 0, because 1 minus 1 is 0, and so on. And then here we can see that we can cancel out some terms. So f of x sub 1's cancel out. Likewise, f of x sub 2's cancel out, and so on, leaving us with only this negative f of x sub 0 plus f of x sub n. Just rearranging this in the other way so we have no negative leading coefficients. We get f of x sub n minus f of x sub 0. And that equals f of b minus f of a on that interval from a to b. Now, since we know that f is integrable on that interval, we do know that there exists an epsilon greater than 0. For all epsilon greater than 0, there exists a partition P such that this is true right here. The absolute value of the sum of these terms is less than epsilon for any t sub I in the interval from x sub I minus x sub I minus 1. And this is coming strictly from homework number 5, problem number 4C. We proved this back then. Now, since we knew up here that f of t sub I of x sub I minus x sub I minus 1 is equal to, and again, this is coming from here, this equals that. Since these are equal, what I'm going to do in the next step is just replace this left part with f of b minus f of a, and that's going to be less than epsilon. And since both of these are less than epsilon, then we can conclude that this must equal that, and that is exactly what we wanted to prove in this problem. So the integral from a to b of f of x dx must be equal to f of b minus f of a. And that's the end. Hope that was clear.